Hello everyone and welcome to today's video on Kubernetes objects. Now in the previous videos I have explained about what is Kubernetes, why Kubernetes, and also I have explained about the architecture of Kubernetes. Now in today's videos, as you can see in the title, that is Kubernetes objects. We will be discussing about different type of Kubernetes objects, see what they are and what they do. Okay, so let's start. So first of all, as we all know that Kubernetes is an orchestration tool, right, for containers, and containers like Docker, especially Docker because it is widely used and mostly used, right? Okay, so what do we mean by objects? First of all, the first question. Okay, Kubernetes objects, let me give you the title. What is K8 objects? Okay, let me give you some perspective on this. Okay, like suppose this is a car. Okay, this is a car. Please pardon my drawing, I'm not a good drawer. Okay, okay, so this is our car. Now if you have a car, what can you do with it? You can ride it, obviously, to go from one place to another, forward or backwards, right? You can drive off your kids to school. You can go to school, colleges, offices, wherever you want to go, right? So this is the usage of car. Now we can think the car of an object, right? It is an object that we are using it, right? So our analogy is also similar. Kubernetes objects are also something that we make so that we can use. To use the car, you have to make the car first, right? There are manufacturers, there are factories that make the car or build the car, and then you use the car for your purpose, right? Similarly, in Kubernetes, you also make some stuffs, make some objects so that you can use them for your purpose. For your purpose. Clear? Okay, let me give you another analogy in this one. Suppose that you have an app, right? Let's say it's an alarm clock. In order to use this app, you have to build it first, right? All the engineers, developers, you have to build the app first. Only then you can use it. So here, our app, after being built, is our object. Clear? If you still didn't understand, let me give you a Pythonic example. If you are familiar with Python, I'm sure you have heard of object-oriented programming, right? So in that, there's something called class. Okay, if you're familiar with Python, you can relate, or if you don't relate, just bear with me in this part. For the Python's lovers, there are something called object-oriented programming where you make object and use them. How? There's something called class, like we define a class A and we give its characteristics like this. Okay, like A. So the class A would have a characteristics called A here, and it also might have a function, let's say run, so that the class runs. Okay, now in Python what do? We randomly create this object like this: A equals to capital A function. When we run this line, an object gets created in A of this class. An object of this class is created in our small a. When we create this object, what can we do? We can use it like I have mentioned above. Okay, we first of all make the object. After we make the object, we can use this. Okay, similarly, after we have made our object A, we can use its function run like this, and it will work. So if you are in Python, I'm pretty sure you have understood the analogy that I'm trying to give you here. Okay, so guys, this was the object and perspective, a perspective that what is Kubernetes objects. We make Kubernetes objects, we build them for using them for our purpose. Okay, and how we build them, what are the codes, what are the details, you can obviously find them in the Kubernetes documentations. You use YAML files, etc. So that is not our talking point today. Our talking point for today is that we want to get introduced to these objects. Okay, uh, how these objects work. Okay, what are they used for? Basically, we're gonna get an introduction. So this was about what is Kubernetes objects. So let's get to our object part, that is discussion on Kubernetes objects. Let's get to the main thing. The first object that we are gonna be talking about. Before that, we all know what this is, right? What? This is a Docker container. Suppose this is a Docker container. I'm representing it with a Docker logo. Okay. What can we do with a Docker container? We can run it, right? But if we just run this Docker container, will it be called a Kubernetes object? No, because a single Docker container has nothing to do with Kubernetes. It is individual. It has nothing to do with Kubernetes. Okay. So in order to make it included in Kubernetes, you have to wrap it up. You have to wrap it up in a cover so that it becomes a part of Kubernetes. Like similar to when you buy a shirt. When you buy a shirt from the supermarket, okay, the shirt may be imported from, let's say, Germany, but you are buying it from your local market, right? So people should know that you have bought this product from your local market, let's say market A or ABC. If you just pick the shirt, will anyone be able to know that this is from your ABC market? Obviously not, right? So what do? They put the t-shirt packaged inside a shopping bag. Inside a shopping bag, in front of which there's a huge sign of your ABC market. So when you put the shirt inside that container, inside that market package, now you can say this: yes, I have bought this product from our ABC market. If you didn't do this, the shirt is independent. It is from Germany. No one knows that it is from you have bought this from your local market, right? Similarly, our Docker container is independent and individual. It works on its own, but if you want to introduce it to Kubernetes, you have to wrap it up. You have to wrap it up. And when you package it up in all the Kubernetes stuffs, okay, like it may be YAML and everything else, it is called something called pod. And pod is our first Kubernetes object. So basically, as you can see, pod is like a package of containers. Okay, the containers get packaged into pods. It's as simple as that. Basically, the containers are getting inside our Kubernetes system. Okay, and what can we know about pods? It is the smallest unit of Kubernetes. There's no any other smaller part. It is the smallest possible object that you can make and run in Kubernetes. Okay, if you go smaller than that, it is only just a container. It is not a part of Kubernetes anymore. If you want to make it a part of Kubernetes, you have to wrap it up in the cloth of Kubernetes, and then it will be called pod. Clear? Okay. Now, one information is that it is the smallest unit. Another information that you need to know, it is really ephemeral. It is a ephemeral, a tough word. It is basically synonymous to short-lived. We all know containers itself are short-lived. Okay, containers can be destroyed, can be built again, can be killed, right? So similarly, pods are also like this. You can destroy a pod, or it might get destroyed. It is not permanent. Okay, it is short-lived. Clear? Like the containers. Another thing is that you can put multiple containers inside a pod. Okay, inside this package called pod, but it is not the ideal or conventional usage. General, we use one pod for one container. Clear? One pod equals one container. This is a general convention, but in some special cases we might use two, okay, two or three, but it is not the convention. So this was our first Kubernetes object called pod. Clear? Okay, fine. Now let's copy this one and let's go to our second Kubernetes object. Okay. Uh, yeah. Should I? Okay. Now let me give you an introduction to this one. Suppose you have built a pod. Suppose first of all you have an app. An app. You have made it a container, Docker container. Then you have inputted it in Kubernetes, that making it a pod. Okay, and it looks like this now. Wait, sorry. Yeah, it looks like this. You have a container inside a pod. Clear? Now you are a company. You have manufactured your container to take inputs, let's say 5k requests, but your popularity grew so much that suddenly on a holiday, let's say 15k people just appeared. So much more requests, right? So can your one single pod maintain all of these requests? Obviously no, it can't. It can't handle this huge amount of load. So what can you do? One thing is that you might think that I can use a huge CPU and huge storage system to cover all it up. But if you prepare for 15k and suppose 40k arrives, what will you do then? It's a problem, right? So how do we solve or tackle this? How do we do that? Okay, We do this by replicating our pod. Okay, we do this by wait oh, replicating our pod. Here now we have two pods. Let's bring another one. Yeah, okay, fine. Let's remove this one. Now we have three pods. Okay, suppose this one can take 5k requests, this one can take 5k requests, and this one can take 5k requests. So if you tackle by chance 15k requests, you can handle them easily. If you have 5k requests, you might divide the request, or you might let's say active this one. These will also run, but these are not having too much loads. Basically you're just distributing the whole load. If now you have 5k 5k 5k, in total 15k request. If more comes like 30k, again what can you do? You will introduce another pod. This is a solution, right? Yeah, this entire thing, that you see is a set. This entire thing that you see is a set of pod, right? You heard of sets, like let me give you an example. Python lists like a b c, this is a kind of a set, right? Or in mathematics you have seen sets like this, represented like this, right? So here this is also a set of pods, and this set of pods is called replica set, because there are replicas of the same pod. These are the same thing, we just made a copy and pasted it, okay. I think I'm clear on this. So basically replica set is our second Kubernetes object. Replica set, it is a basically a set of the pods. It can have multiple pods. Here we can see there are only 3 pods, right? Only 3 pods. If we need more, okay, in the we all know that in Kubernetes we use YAML file for configuration. There is a parameter called replica where we mention how many replicas we want. If there's an instance that you need more pods, like we need 2 more pods, we just simply input the replica from 3 to 5. We just edit this and again run it. You will see 2 more pods created. It is so simple, so simple. Just imagine you don't have Kubernetes. And you have double or triple times the request. What will you do? You again have to create storage system, etc. Again do manual labor, etc. It is time consuming, costly, everything in the negative. Okay, this is where our second object replica set comes in. So I think I'm clear. Replica set of pods. Okay, now our third object. Replica set in general actually not created. Okay, it is handled by a bigger authority. It is packaged in a larger package itself. Okay, now we are talking about lot of packages, right? The container is packaged inside the pod. The pod is packaged inside the replica set. And the replica set is packaged inside what? Called deployment. So our third Kubernetes object for today is deployment. Now why do we need this thing? Why? First of all, when we create Containers, the YAML file. We don't create any pods generally. We don't create even the replica set. We directly create the deployment, okay, in the YAML file, mentioning all the parameters. Okay, the replica that I have mentioned a bit earlier, you can use it here too, which will automatically create the entire thing inside, this whole thing inside automatically. So you don't have to manually first create this pod, then create replica set to create this and this, and then create deployment set. No, it is too much time consuming, it is not efficient. Okay, rather in a real life we only create the deployment set mentioning on the parameters, and automatically everything that you see inside of the deployment gets created from the replica set to the pods. Clear? Okay, now the question is why do we need it in the first place? In the previous lectures, or the first lecture if I'm not wrong, I have mentioned why we need Kubernetes, why do we use Kubernetes, right? In that I have mentioned about a feature, a certain feature called auto scaling and auto healing, right? So in Kubernetes there are these two features. By auto scale, like I have shown a bit earlier, that what you can do, you can create 2, 3, 4, any number of pods that you like by just changing one parameter very easily. Okay, if you need more pods, you can create more pods. What does auto healing mean? Auto healing is also similar, that if a pod gets destroyed, like this one, it will remove it and create a new pod in its place. Clear? If this one gets affected, it will remove it and create a new one in its place. This is called auto healing. Okay, fine. This auto healing, auto scaling is overall managed by deployment. This is why first of all we need deployments. It sees the replica set. The job of replica set is to maintain the consistent number of pods. Like if you have inputted replica equals to 3 in your YAML file, at all time there should be 3 pods running. At all time. Like I have said, if anyone fails, it automatically deletes that and creates a new one. Okay, the replica set always sees this, it oversees the consistency of the number. If anyone fails, it instantly notifies deployment, okay, and gradually the process of auto healing takes place. So first job of deployment is to look over replica set to ensure the consistent number of pods are running at all time. Okay, first point. The second thing is updating. Updating. Now what do I mean by updates? Okay, suppose you have an application. Okay, these are run in these 3 pods, replicas, copies of your application. Now you suddenly face some you need some updates. Okay, let me give it in another space, it will be easier. Suppose these are containers, containers 1, 2, 3 and 4. These are being used. Being used. These are running. Okay. Not that you have stopped or anything. It is, these are all running, full functional. Users are sending requests and you are serving them. Clear? Okay. Now you need an update. There's a bug, you need to fix it. So as the so as a product manager or the head of the uh, infrastructure or and else, do you stop all of these pods, make the update, and then put them back on? Do you do this? Well, no. Why not? Because you are already running these applications inside the pods. Now if you stop this entirely, then what will happen? Users will lose connection. User lose connection. It will be dead for some time, right? Dead for some time, which will create what? Negative feedbacks for your application, your company. Negative feedbacks, right? And which will eventually mean cost, time, negative growth. Okay, it will be a downward growth. Reputation will be lost and everything. So basically, it is not a good thing. You can't just stop the entire process to make an update, right? So what can we do and what do we do? Especially in Kubernetes, we use something called deployments, and deployments has a special feature of updating. There are some strategies. Let me just give you an overall idea. Among the strategies, one strategy is called rollout. It is called roll out. What it does is that it updates the app while it is being run. Okay, updates while running. So these pods are running, right? So what it will do is that it won't change everything. It will pick this one and change it, update it. These are running in the version, let's say version 1. It will change this one and make it version 2. Users are gonna using these three. They are not gonna be dead. Okay. Users are now going to be using these three and it will make changes in this one. After completing this change, this is in version 2, it will pick this one. These three are gonna be running. It will make this one version 2, it will pick this one now. These three are running. So like this, it is implementing the change in a rollout, in a sequence. Okay, it is picking one and changing, picking one and changing, picking one and changing. It is not stopping the entire process. Okay, users are using the other versions, other containers, other pods. The downtime is now very little. Okay, you just handling one pod at each time, never stopping. You are continuously giving the service but continuously updating as well. Okay, it is called roll out or rolling update if you prefer. Clear? Okay, so deployments gives us this facility of updating. So what does it do? It reduces downtime, as I mentioned, reduces downtime. Okay, and makes our updates very easy. This is why we need deployments. Clear? Okay, so deployments are our third object in Kubernetes. From creating pod to replica set and deployments, let's move on to our fourth one. Now the fourth one is exactly the same. Let me see if I can copy the whole thing. Let me check. Yeah. Now, for the later part, what is the discussion point? Now, in your app, suppose in your app, you are using databases. Okay, suppose you need a database. This is a database. Suppose it is a data. If you don't know database are like a storehouse where you store the data. Like you have a, let's say, login page where you put the name, your emails, etc. So when you input this, it goes to the storehouse in the database, and it stores this name and email, so that if you again come, it can check that it is you and give you the access. Okay, so this is database. Now suppose you are using a database in your application, okay, and running this pod. Now as I have mentioned, pod can get deleted, pod can get corrupted and destroyed. For some reason your pod is dead, it is not working. Okay, now what will happen? All the data that you have stored inside the database, like all the login names and passwords and emails, everything, it will get lost. Okay, what is the problem? If one pod gets destroyed, I'll create a new one. Okay, now you created a new one. Suppose this is the new one, but what is the problem here? You have created the new one, but the data that you have here are gone, no data. You are starting from scratch again. So as a user, how will you feel that each time if you log into a page, each time you have to type in your name, password, email ID again and again? Or for a bigger company that has millions of users, okay, suddenly it forgot all of its users. How will it that be? Like Facebook doesn't know you. Again you have to type in your name, etc. It just completely doesn't know you. All of your identity, everything is just got erased. Okay, like say you have 5 years of activity in your Facebook page. Okay, now suddenly the pod that is handling the Facebook just got destroyed. Okay, they have created a new one, but you see you are not even in Facebook. It doesn't recognize you. All the works that you did in 5 years are just completely gone, and you have to start from creating a new account. So it is a huge problem, right? Yeah. So this is why we need a separate space, a separate database. How can I draw it? This is why we need a separate storage, that yes, I will be storing my data here. Okay, all the login files and everything will be stored in this uh, pod database, as well as another database in another location. If this pod gets deleted or get killed, your data is still present, your data is still active. Okay, if you create a new pod, if you create a new pod, the new pod will automatically get connected to the your database. Automatically it will get connected with the old database, and it will be able to identify you because your name is here, your name is present here, so it will easily pick you up. Clear? Okay, fine. Okay, let me just give a pause for a little bit. So I hope you got my point that the data is always stored at a particular place. Okay, and the pod basically connects to this. Okay, the data is collected in its database as well as the other one as well. So in case if this pod fails, the data still remains in this one. So when you create a new pod, it automatically connects to this and gets all the previous data. This type of application is called stateful application, because you really need to know what happened earlier. You need to know the history of your pod or container or app. Okay, without the history of pod your pod or your application won't run properly. It will be inconsistent and it will create problems, like I said. So this type of applications is called stateful apps, or in case of pods it's called stateful pods. Now the thing is, the point that I want to put up is that in deployment, what is happening, we are just creating these pods. Okay, if anyone fails, we are just creating a new one. But are we storing the data of each of the pods or containers here? The data, when these any of the pod is destroyed, the data is also get destroyed with it, because we are not storing anything, right? Okay, now if you are using, let's say, any database application like, let's say, MySQL, or there can be Redis, which are basically databases. As I have mentioned, for database you really need to know the history or the past activity. Okay, so in that case, in Kubernetes you need a separate storage as well, and this storage is called something called what to write, yeah, it is our next Kubernetes object called PV, persistent volume. Persistent volume. Okay, persistent volume, it is for the clusters, the entire thing, the entire ecosystem. Okay, and if a pod needs it, it just claims it, and the claim is called persistent volume claim. In the YAML file, you just configure it or create a persistent volume claim object, and you just put the name of your container so that it can use it. Okay, you just assign the persistent volume to a pod by persistent volume claim. Clear? So we have discussed why we need this persistent volume, okay, and its usage. Clear? Okay, so this was our Kubernetes object number 4. The object number 5, it is quite relevant to our persistent volume because it also uses it as a tool. Okay, it also uses it as tool. Like how? It is a brother to deployment set, deployment, and its name is stateful set. Our Kubernetes object number 5, stateful set. What is stateful set? Well, you see this type of application that needs the history. These type of objects or these type of applications are handled by stateful set. So basically what I am saying is that if it is stateless, no history needed, then we use deployments. But it is stateful, like a database. You really need to know the history. It is a must. You need to know it. Otherwise, it will result in problem. There, the deployment, it is stateful set. And the difference between the stateful set and deployment is basically the PVC. This is the difference. Stateful set maintains a PVC. With a stateful set, you introduce a PVC to your pod, a specific space or storage in your local machine or in your cloud, so that if any pod fails, if you create a new one, it automatically can get the previous history of stored data and make corrections, make applications, make adjustments, and its usage accordingly, so that it doesn't forget you who you are when you log into your application. Clear? This is the difference of deployments and stateful sets. Okay, these two are in the level of this, in the same level. It is used according to your use. If you are using stateless application, you will be going for deployment. If you are using stateful application, you will be going for a stateful set. Okay, almost the same thing. One uses the PVC that I have mentioned earlier and one does not. Clear? Okay, but these two are in the same layer. You use either one or two. Clear? Okay, fine. Now the next Kubernetes object. Okay, let let's discuss the necessity of our next Kubernetes object, shall we? Yeah, let's say you have a node here. This is a node. You have another node in your cluster. I hope you guys know what's node, right? I have discussed in the previous lecture or session, you can say. If you haven't watched that, go and watch that and have an idea about nodes in Kubernetes. So this is our node 1, this is node 2, and this is node 3. Now in Kubernetes, it is really important to monitor and log that whether your applications and the deployments, the pods, all are running correctly. You need a dashboard or some information, the logs about all the health of your services or objects. Okay, so if you want to know the logs and monitor, as a developer, should it be for only this node or this node or this node, or for all the three nodes? Obviously for all the three nodes, right? Monitoring and logging is needed everywhere. You can't just forget about one node and not monitor it, right? Yeah, obviously. Now let's say for logging and monitoring, you need a separate thing in each node so that you can monitor it. Okay, let's say a pod, and it is actually a pod consisting of the logging and monitoring abilities. When you put it inside a node, it gives you the logging and monitoring power of Thor. Yeah, okay. Now suppose you have hundreds of nodes, and you need to log and monitor them. So what will you do? You will put a pod here, monitoring pod here, then here, then here, then the rest of hundreds and thousands of pods. What will it mean? Time, cost. You don't have that much time. In production, you will be using so much nodes and stuffs. It is really time consuming if you manually put one by one by one. Okay, this is where our next Kubernetes object comes in, which is called the daemon set. Daemon set. It basically puts this pod at all the nodes one instance. At one go, it creates a pod, a service throughout the nodes. Or if you select that, by chance if you select, I need these two nodes to get present with this, it will create the same thing on your selected nodes, and it by default it will create the same thing in all of the nodes. So if you create all of the create the pod in all of the nodes, it will save your time. You don't have to do it individually. Clear? So if you want to do something in all of the nodes or your selected nodes, you will be using daemon set. Clear? Okay, fine. So the next Kubernetes object, yeah, there are I guess 53 Kubernetes objects if I'm not wrong. So there are lots of Kubernetes objects, but I'm mentioning the most important ones or the most used ones, okay, so that you can get introduced in the ecosystem. The next one is, suppose you have a task, let's say task 1, a random task, okay, you need it to be performed, but you don't need it after it gets completed. Like you asked your brother, hey, just can you bring me some water to my desk, I'm busy in study. So he brought the water, the cup of water in your desk, okay. After that the job is finished. After you have finished, he has finished the job, is it any necessary to appoint him the job that you will keep on doing it again and again and again and again and again? No, it is a one timer job. One timer, it is a one timer task. After it is done, you no longer need it. Okay, similar to this, if there is any task that is one timer, after that you don't need it, if you still put it, it will cost you space, right? It will cost you money because you don't need it but you're still running it. Okay, in some cases it might cost you inefficiencies and inconsistencies. So for those jobs or those tasks or those applications and pods need to be run one time, you can create, the name says it, job. One job, you create job. Okay, for one job, for one single task, you create job. So job is a Kubernetes object if you need any one timer task. Now you say, hey little brother, you ask your small little brother that whenever I get to study at 6 p.m. every day, your task is to bring me water at my desk. This is your duty. So he has to do it not one time, every day at 6 p.m. when you start studying. If this is the case, if there's anything related to scheduling, then this job is called cron job. Cron job. Clear? One is one timer, the other one is scheduled. Clear? This is the difference. After these tasks, they get deleted. The job gets deleted, and the cron job, I guess it gets deactivated, and whenever it is needed, it again gets created, if I'm not wrong. Okay, but the concept is like this: it is scheduled, the other one is one timer. Now you might wonder that if my pod gets destroyed before running, well, in that case a new one gets introduced. You will have your job, don't worry, it will be completed. The deployment set or whatever there is in the background will create it for you if it gets failed, but you will get the job, and after completing the job it will get destroyed. No space needed, lost, or anything. So job and cron job are done. Okay. the next the next Kubernetes object. So for this one, let's say you are a software company, an app. So you have two teams, team 1, team 2, building the same app, building the same app. Now suppose this is the code. This is the code. Suppose someone from team 1 made a change. Let's say he added A to the code. Okay. Now the code changed accordingly. Now when the team 2 sees the code, he will be shocked. Like, what? What just happened? I was building something called B, which should have taken, uh, which should have solved this one. How did it get solved? Or I have created something, but it is getting a conflict with this A. Okay. So why? Because they are using the same thing. If one makes a change, if team 1 makes a change, it might conflict with the workings of team 2, right? In this case, what can you do? If you are familiar with GitHub, I can give you an analogy with the GitHub as well. Like for GitHub, what do you do? For GitHub repo, you create branches. Let's say branch 1 and user 1. User 1 works on this branch. And you get branch 2. User 2 uses this one. So you both are working on the same code repo, but you are not conflicting with one another. He just took the code from this one, user 1. Also the user took the code from the same place, but their contribution are not getting conflicted. They are using the same thing separately. Okay, I hope this is clear. You can say it is a version 1 and version 2 of the same thing. The similar utility facility is also present in Kubernetes, that is called something called namespace. Okay, so like let me give you the illustration. Suppose this is a what can I say, this is your cluster. There are nodes inside. So what you do is that you make the same copy of the cluster. Can I pick that? Yeah. You make a copy of the cluster of the same thing. The same thing is here and here. And you give one copy to the team A and you give another copy to team B, so that they can work on their project separately without conflicting with one another, without creating any problem among themselves. Okay, so namespace allows you to make versions of your or branches of your same thing, so that you can have isolated environment to work with. After you have worked, you might consider to pick one version. Like let's say team A has made some changes and it made it better. Team B also made some changes, it also made it better, but team A's are the best, so you pick this cluster and use it. Okay, it's like the GitHub example I gave you. Everyone uses separate branch to work on their progress issues, and after working they make a pull request and select whether to merge with the real code or not. the authority selects it. So the similar thing here also. Namespace allows us to have isolated environments or versions so that we can separately use the cluster so that no conflict arises. Clear? It is like version 1 and version 2 of the same thing, so that you can just uh, uh, maintain or create, build yourself isolated. I hope I am clear. So this was namespace. Another thing, another thing, another Kubernetes object. Let's say that you have team A and team B. Okay, you have clusters, you have made some namespaces, but you want that team B should not be allowed to use node A, so node 1. So how can you do that? You can restrict the usage of uh, clusters, okay, or namespaces through roles. Okay, you can just restrict them that you can use this but not this. You can do that by using something called roles and also role binding. So basically almost the same. One restricts you and one I think assigns you, if I'm not wrong, um, to the task, if I'm not wrong, because these are quite similar. Okay, so basically they just assign you the task and restrict you from uh, whatever it is not for you. Who does this thing? We all know there is something called master plane or master node. You can create the node and roles and role bindings so that you can separately assign tasks and restrict anything from the namespaces or the teams. You use master node to do so. You use master node to do so. So this was the roles and role binding. Okay, so yeah, so guys, this was it. I know the video got really long, but I tried to introduce you to the Kubernetes objects. So let's give you a summary and conclude our long session for today. First of all, I have introduced you what is Kubernetes object. I gave you some analogy so that you can understand. Next, our first object was called pod, the smallest unit of Kubernetes that just encapsulates the container. The second one was replica set. Replica set was basically some copies of the what? Some copies of the same pod. Replica set. Replica set gets packaged by what? Deployment. Deployment. Right? Deployment. Now, if our application is stateless, then we can use deployment, but if it is stateful, then we use stateful set. And what's the difference between deployment and stateful set? The primary difference is basically one uses something called PVC, that is persistent volume claim or persistent volume. What is that? It is basically a separate storage so that you can store your data, okay, in your local machine or your cloud separately. Okay, so if you create any uh, new uh, new pods and anything, the new pod gets connected with the previous history. Okay, it doesn't lose the history and act upon it. So this is PVC. Next we have seen jobs. If you need anything one timer, you create jobs. If you need to schedule, you need cron job. If you are eager, you can search this part, cron. This is basically scheduling. There are some format of scheduling internationally recognized throughout the field. Okay, it is called cron. Please search that if you are eager, cause when we are using cron job, we will be using that format. It is basically a format of date time, or you can say a format of scheduling. Okay, next we have discussed about what? Namespaces. Namespace is basically you create isolated environment version 1 version 2 of the same thing, so that your teams can work separately on the same thing. It is like GitHub repo. You can create branches and use separately, and after your work done you can commit it, merge it if you like it all. Okay, this was namespace. And we can assign roles and duties or restrict them by using role and role binding. These are different things, but for now I'm just introducing it to you. I'm a little bit confused on this thing, so if you are eager to learn it earlier than me, yeah, or correct me, go ahead. It is gonna be fun. Okay, these were the 10 Kubernetes objects that I have discussed so far. I have forgot to introduce you to two more, that is ingress and service. So in really short time, okay, in really short time, let's also get introduced to our Kubernetes object called ingress and service as well. Okay, it won't take much time, so don't worry. So this was our deployment, right? Suppose this pod over here has a link. Let's say 172.103.a.b. Suppose this is some kind of ID. If anyone from anywhere from the world types this and enters this, he will be directed to this pod application here. But anyone can't just enter, can they? Can anyone just enter into your house? No, they have to go through your main gate, right? Main gate of your house. And the main gate of the pod here is ingress. It is the main gate of your entire, let's say, nodes. Any outside call, it basically handles outside calls. If anyone HTTP request, HTTPS request, anything to activate the pods, it will first go through the main door or main gate or the reception, that is ingress. It will take the request first. Clear? This is called ingress. You can put on restrictions. This is why it is important. You can put on restrictions. It can do lots of stuffs here. This is why you can create a separate object to handle the whole entry towards your pod. You can control it by using ingress. But after we get into the system, after we get into the replica set, let's say, which pod should I go? Which pod should I go? Which pod for fulfills my request? Is it this one? Is it this one? Or is it this one? Okay, I don't know the pods. Who knows it? There's someone who knows it. It is called our next Kubernetes object called service. It is called service. What service basically does, in your replica set, if you have 3 replicas, it will have 3 places. 1, 2, 3. And it will give some ID. Let's say ID1, ID2, ID3. It has 3 spaces since replicas are 3 and 3 IDs. So regardless of the pods, let's say our 3 pods are on ID1, ID2 and ID3. They will get some kind of ID. Okay. If this pod gets deleted somehow, okay, and a new pod comes in, it will still have the same ID because it is in the same spot. This is why it is in the same ID. Suppose if you don't create this system, what will happen? What will happen? Let's say you have these three pods and you have an ID called, let's say, 1, 2 and 3. Okay, for some reason this one gets deleted. Okay, and another new pod gets created. Since it is auto healing, it will get a random new ID. It will get a random new ID. It might be 100 or anything, if only if you don't mention service. Now, as a user or as an application, if a new object comes in and it gets a new ID, the system will get confused. Wait, what? There was something called 5 a bit earlier. Now it is 100. Who is he? I don't know him. What is his role? Or you might get, who is 105? Who is this? I knew 5, but where is 5? It will not know him because pods get their unique random ID. If it is destroyed, it gets a new one. The new pod gets a new ID. But if you use the service here, the IDs stay constant. You have a constant ID, and that is why the systems don't get confused. It is far more easier to process that yes, this pod is ID1 and it will stay like this. Okay, this is one of the major facilities that service provides. It maintains a constant connection between the pods so that no pod gets confused or create an inconsistency in the system. Like I said, if you get a new ID where you had 5, if you get 105, the system get confused to notice you. Who are you? I had 5 in place of you, right? So to avoid this, we use service, and the service maintains the pod connections through these ID numbers. The ingress takes this request, it handles the call, sees if it is valid or not, or whether any restrictions upon it. Then it passes down to the service. The service checks what type of pod needs to be handled here, what type of pod needs to be assigned for this request, and what ID does it have. It checks the ID. If it is assigned or related to ID1, it will just pass it down here. If it is related to 3, ID number 3, it will pass it to 3. But the main thing about service is that it always maintains a constant identity of the pods. This is very important. Again, I am saying, if there is a continuous change in the ID of the pods due to auto healing, etc., then the system gets inconsistent and creates lot of confusion and problems, internal problems. The application might not work. The entire application, if the pods are internally connected, then it might create really big problems. This is why we need services to maintain the network within the pods perfectly. So yeah, guys, yes, we have done it. In this awesome session today, I have discussed about the Kubernetes objects and these 12 specific objects. Basically, I have introduced you to these objects. There's no code, just how they work and why do we need it. So if you find it still a bit tough to understand, I will be linking the blog to the same discussion that I have done today. So if you still feel stuck, you can rewatch the video obviously and also see the blog. So this was it for today. We will be seeing you on a new Kubernetes topic discussion. So for then, bye bye.